All right, so this PowerPoint presentation is going to be on alkalinity relationships, alkalinity milligrams per liter as CaCO3. This is going to be alkalinity math. Here we have the alkalinity relationship chart off the state of Florida formula sheet. Now, why do we need to know how to use this? Well, it's on the exam. At least in the state of Florida, it is. This chart is used to identify the amount of alkalinity available, and that can be used in softening. Now, I don't work at a softening plant, so I'm not entirely sure how to use this. I'm still learning, but I do know how to do the math, so let's help you with that. So I'm going to try to explain this chart to you the best I can, because even when I look at it, I'm like, what is this thing? What it is five separate math equations. One, two, three, four, five. So each one of these lines is a different math equation. So you ask, how am I going to know which math equation to use? We're going to go to your first little column here, results of titration. They're going to give you that on the test in the exam. You're not going to have to find that on your own. Now, if you work at a softening plant, you're going to have to find it on your own. But this is a study guide for an exam. Well, what are the results of titration? You're going to have P alkalinity, I can't pronounce that word, and T total alkalinity. Apparently, I can't pronounce alkalinity either. And then you're going to find the relationship between those two, and that's going to help you decide which math equation to use. So for a quick example, if the results of your titration were that P alkalinity was equal to 0, well, this is the column you're going to use. And that would mean that bicarbonate alkalinity would be equal to the total alkalinity, your carbonate alkalinity would equal 0, and your hydroxide alkalinity would be 0. Now, for another example, if the P alkalinity is equal to the total alkalinity, that means that there is going to be 0 bicarbonate, 0 carbonate, and that all of your alkalinity is going to be hydroxide. Hopefully this is starting to make a little bit of sense, yeah? So let's say that your P alkalinity was equal to 1/2 of the total alkalinity. So if your total alkalinity, you divide it in half, and that equals the P, that means that you would have 0 bicarbonate alkalinity. Your carbonate alkalinity would be 2 times the P alkalinity, and your hydroxide alkalinity would be 0. Trying to explain the chart without having a question with it, it's getting a little difficult. So let's jump into some of these questions. Given the results of the alkalinity test shown below, calculate the alkalinity constituents as milligrams per liter. So you have phenol alkalinity at 29 milligrams per liter and total alkalinity at 57 milligrams per liter. So here we have our alkalinity relationship charts. So again, we're using this first column. Well, the P alkalinity is not equal to 0, and the P alkalinity is not equal to the T alkalinity. So now we have to use this part right here to determine which equation we're going to use. So we're going to take our total alkalinity and divide it by 2. So the total alkalinity, 57 milligrams per liter, divide that by 2. And half of that is 28.5. And so our P alkalinity is actually greater than 1/2 the total alkalinity. So we're going to be using row 4. P alkalinity is greater than half the total. So I went ahead and I broke this out of the chart to make it a little bit easier. Remember, we said that the P alkalinity was greater than half the total. So our bicarbonate is equal to 0. So there's your 0 and your bicarbonate. Our our carbonate alkalinity is 2 times the total alkalinity minus the P alkalinity. And your hydroxide alkalinity is equal to 2 times P minus T. All right, so now we can plug all that info in. Remember to solve for the brackets first. So again, bicarbonate was equal to 0. Your Carbonate alkalinity is total alkalinity, 57 milligrams per liter, minus P alkalinity of 29 milligrams per liter. And then you're going to times that by 2. For your hydroxide alkalinity, it's 2 times your P alkalinity of 29 milligrams per liter, so 2 times 29. And then you're going to subtract your total alkalinity of 57. So we did our brackets first. So now you have bicarbonate is still 0. Your carbonate alkalinity is 2 times 28 milligrams per liter. And your hydroxide alkalinity is 58 minus 57 milligrams per liter. So you have bicarbonate alkalinity of 0, your carbonate alkalinity of 56 milligrams per liter, and your hydroxide alkalinity of 1 milligram per liter. All right, let's do another one. Given the results of the alkalinity test shown below, calculate the alkalinity constituents as milligrams per liter. So your P alkalinity is 23 milligrams per liter, and your total alkalinity is 71 milligrams per liter. So here we have our chart again. So our P alkalinity is not equal to 0, and it is not equal to the total alkalinity. So we're left with the 3 columns in the middle, and to do that we need to know half the total alkalinity. So we're going to divide 71 by 2, and you get 35.5, which means that the P alkalinity of 23 is less than half the T alkalinity of 35. So we're going to be using row 2. All right, and breaking it out of the relationship chart again, we said P was less than half the total. So bicarbonate is going to be equal to the total minus 2 times the P alkalinity. Your carbonate alkalinity is going to be 2 times the P alkalinity, and our hydroxide alkalinity is going to equal 0. So we have 71 milligrams per liter of total alkalinity minus 2 times the 23 milligrams of P alkalinity. And then our carbonate alkalinity is going to be 2 times the 23 milligrams per liter of the P alkalinity. So in your bicarbonate, you did 2 times 23 milligrams per liter, which gave you 46. So now you have to subtract that from the 71. And your carbonate alkalinity, you multiplied the 2 times 23 and got your 46 milligrams per liter. When you finish your math for bicarbonate, you get 25 milligrams per liter. Carbonate was 46 milligrams per liter, and hydroxide was equal to 0. Given the results of the alkalinity test shown below, calculate the alkalinity constituents as milligrams per liter. So P alkalinity is 20 milligrams per liter. Total alkalinity is 40 milligrams per liter. So again, we have our chart. P alkalinity is not equal to 0. P alkalinity is not equal to total alkalinity. So that means we're going to have to divide the total in half so we can get our relationship. 40 divided by 2, and that gives you 20. So the P alkalinity of 20 is equal to half the total alkalinity of 20. So that means we're going to be using row number 3. P is equal to 1/2 of T. Row number 3, P alkalinity is equal to half the total, shows that bicarbonate alkalinity is going to be equal to 0. The carbonate alkalinity is going to be 2 times the P alkalinity, and hydroxide alkalinity is also equal to 0. So you're going to do 2 times 20 milligrams per liter, and that gives you carbonate alkalinity of 40 milligrams per liter, while again, the bicarbonate is equal to 0, and hydroxide is also equal to 0. Given the results of the alkalinity test shown below, calculate the alkalinity constituents as milligrams per liter. P alkalinity is 40.04 milligrams per liter, and total alkalinity is 70.49 milligrams per liter. Here we have our chart again. The P alkalinity is not equal to 0, and it is not equal to the total alkalinity. So again, we're going to have to divide the total alkalinity in half so we can find the relationship. 70.49 divided by 2, and that gives you 35.245, which means the P alkalinity of 40.04 is greater than half the total of 35.245. So that means you're going to be using column number 4. P is greater than 1/2 of T. So again, based on row 4, bicarbonate alkalinity is equal to 0. The carbonate alkalinity is equal to 2 times the total minus the P alkalinity. And the hydroxide alkalinity is 2 times the P alkalinity minus T alkalinity. Plug all that in. You're going to solve your brackets first. So you're going to have 70.49 milligrams per liter, the total, minus the P alkalinity of 40.04. And then you're going to multiply that by 2. And then you're going to do 2 times the P alkalinity, so 2 times 40.04. And then once you solve that, you're going to subtract the total alkalinity, 70.49. So do your math in your brackets. So you had 30.45 when you did subtraction, and you did your multiplication, you got 80.08 for your hydroxide. So we have 2 times 30.45 for your carbonate, and for your hydroxide, you have 80.08 minus 70.49 milligrams per liter. So our answer in the end is our bicarbonate alkalinity was equal to 0. Our carbonate alkalinity was equal to 60.9 milligrams per liter. And your hydroxide alkalinity was equal to 9.59 milligrams per liter. So there you have it, alkalinity math. Hopefully I helped you learn how to use this chart a little bit better and I didn't confuse you more. Again, I'm learning and trying to help others learn as well, doing my best. So if it helps you, that's great. Thanks.